right? So it's different, right? We have seen it before, but still we know that this is the time. And why is that? Because so yeah, the point is that you need to get a new object, right, which you haven't seen it before, right? But you understand that. You understand that this is a specific type of object. You know that this is a array, or you know that this is right? Even though you haven't seen that kind of object before. So that is what one aspect of human intelligence. Right? So it's ability to recognize patterns, ability to recognize characters, and then give kind of associate to that particular object. Right? That is one aspect of human intelligence, and that is what AI systems do. So AI systems you give set of data, then over the time, right? As you train it has the ability, has the intelligence to identify those patterns and identify what is happening exactly without explicitly telling what is happening. So it's not like, let's say, putting that as another example, it's not like when expense from expense two. You don't tell AI to like see the addition. It knows based on the query that we have to add it and we come up with what a PI statement now. We tell you from the source. Just as an example, it has to do even for the and machine learning, so it's a branch of AI. Basically, it's kind of a similar point. So basically, you understand data, and without being explicitly trained, without being explicitly programmed for what to do, it identifies the pattern and it builds the logic. That's the logic over time. So when it is used, it enables systems to predictions, mainly AI is for predictions, for decision making, classification. These are the kind of problems that where AI is actually used. And data science is again it's the main domain I would say. So data science actually comprises of AI, machine learning, and most of the algorithms. And it's interdisciplinary area where we have mathematics, computers, statistics, logic, and all these various things. And even the scientific methods. That's where you know, okay, so now artificial neural network. So when you say AI, artificial intelligence, right? So the way these algorithms are developed, right? Basically the underlying motivation or the underlying feature of it is that it tries to mimic human brain. So if you consider this top image, it's a neuron in a human neural neuron, right? And then we have like literally billions of neurons. Technology. In the center of literally billions of neurons. Each neuron is connected to different neurons. So it's a very complex network. Each neuron is connected to multiple neurons. There are something called as dendrite. And each neuron is also basic treatment of neurons and how they function essentially. So it's just a very complex structure, and that is the inspiration or motivation for artificial neural network. So here we try to mimic it. So we define a neuron which takes multiple inputs and it processes that input. So we have some kind of functions defined for the inputs, and then we get the output. Human brain or the human neuron system is kind of extension of artificial intelligence, and we try to mimic it. So in the kind of neuron, it takes multiple inputs. So it takes one explore all the inputs, and then for each input, we define what is called as weights. So weights means essentially how you process that input. And then there is something called as bias, and then we get out as one. Okay, so conceptually it's kind of similar to neuron, and then the final output. Here if you see it's a summation of it's kind of a weighted summation of weights and names at a very basic level. So with just one neuron, likewise we have like hundreds of neurons connected together, right? And that's how the AI systems they are created and then that's how they work. Okay. So then another definition is about the deep learning. So deep learning is again it's specialized AI. Where the learning models or the neural network models are very complex and very deep. So they are like literally tens of multiple neurons in each layer. There is the inputs from, if you see that this particular, right, the input from each neuron or each node here is going to all other neurons. And so it becomes a very complex structure. And the result is called deep learning. So the more deep we go, the more, let's say, the layers we have, or the more number of neurons we have, it's a better system because then it can identify the patterns or identify the outputs properly. Compared to, let's say, a simple neuron. The first example that I showed was a single neuron. So compared to that, this one has this one typically gives a better accuracy. So this is the deep learning. So all these are like kind of related. I mean, AI, ML, deep learning, they are all kind of related. Essentially, we are making computer systems to have the intelligence. So computer systems on its own to identify patterns or identify the logic and what is happening. So let's say if I have to go, and I'm going to have some examples later, but let's say the typical example is like, let's say the classification. So for example, let's say you are given images, like I mentioned like face and law, right, initially. So similarly, if you see, we have a feature in Google Photos and most of the Photos application to have the photos grouped according to people. Right, I mean that you must use it, right? So there is a people tab where you see, like let's say more photos together or right, others go out together. Now how does it identify it? Right, so that it does it what is called as classification. So when it gets a new photo, right, from the new photo, it tries to identify pattern. It tries to identify face, who this photo belongs to, or who is actually in this photo. Right, it tries to identify that, and based on that it groups it. It's not like manually we don't do it. Manually we don't say that this is my photo. But it's automatically done by the Google Photos and ancillary applications. So that's again AI. So that classification is one aspect of AI which is again extensively used. Okay, so because some more research types of machine learning. So there are broadly three types. One is called as supervised learning. Supervised learning is we give actually the input data that we give. Right? So we actually give the output also from the past information. Right? So for example, let us scenario where again the classification, like let's say if you have the pictures of animals, right, cats and dogs. So we give like let's say hundreds of photos. We say that this photo belongs to a cat, this photo is a dog. Right? We give lots of this information, and then the AI system learns it based on that. So that is called as supervised, where the algorithm learns from the labeled training data. So labeled data means we know the output beforehand. So we have a data where we know what is this output. Right? And then that's that kind of output that we give to the algorithm. And the goal is to learn mapping from input to output. So based on the input, it learns and then predicts what can be the output. So mostly this is our prediction type of scenarios. So the examples are regression or numerical values. So let's say predicting, let's say stock prices, predicting, let's say even the sales projections, right? If you want to predict what will be the sales for the next 3 years, right? So that is also a regression of the prediction type of algorithm. Then there is the classification.
which is classifying, like I mentioned, like let's say pictures from animals, pictures to classify appropriately. Now there is the credit risk assessment. The credit risk assessment is a classification where now let's say someone applies for a loan, right? Now the financial institute or the bank, they do analysis. They do analysis that what is the credit risk for this particular loan, which means what is the chance that this loan may not get paid back later. What is the chance of risk? Right? So that is the classification, which means either you say that this loan is risky or this loan is not risky. So I kind of approve or not approve. So it's a classification kind of problem. That is also the supervised learning. The way it works is that, the banks have all the past data. They have all the data for loans disbursed for the last several years. So they collect all this data to know that these are the parameters, and for this particular loan, let's say there is a default. For this loan, there is no default. So it has all this bunch of data for the last several years. Now that data, it gives it to the AI algorithm. And AI algorithm identifies the pattern. So AI algorithm may say that, again, just as example, it may say, which is kind of obvious, that someone who has a lower income has a higher chance of default, right? So then they keep a criteria. They keep a criteria that if you want to give, let's say, 10 lakhs of loan, then you should have this much minimum income. Otherwise, they won't give it, right? So that is based on some of these algorithms. So this is obvious one, but there can be a complex patterns. There can be patterns for parameters like demographics, so which means like age, location, where someone is living, what kind of, what's the purpose of a loan? What kind of products that that the person is trying to purchase, right? So all of that is kind of factored into that, and then we have a credit risk assessment or credit risk classification kind of algorithm. So that is all supervised learning. Then the next part is unsupervised learning, where we don't know the outcome. We don't know exactly, we don't have the past data which actually gives, like let's say this is the classification. Now this is, as I mentioned, like, let's say the loan default, yes or no. We don't have that information. We just have the information about all the past loan applications and all. And then the algorithm tries to identify the pattern and tries to do the classification. So this is more difficult. This unsupervised learning is much more difficult because there is no prior information. There is no data available that what is this classification about, right? I think let's go back. I think, yeah. So that picture classification, it's also unsupervised learning. So we don't say that this is picture belongs to me or this picture belongs to him, right? So the pattern as such the algorithm identifies on its own. And the third category is reinforcement learning, which is it's kind of a simulating kind of a games that you must have like played games, right? Mobile games and all, right? So it's kind of a simulating game kind of scenario, which means let's say a user does certain action, right? A user does certain action, then what is the benefit that user gets? So like let's say a game where maybe like what an online cricket game, if you hit a bat and then it goes to 4, we get those points, right? So it's a reward that that user gets while performing a particular action. Now this is again a very simplistic scenario, but this is kind of built on top over the multiple, let's say the actions and rewards kind of scenarios. So if I do a particular action, what will be the benefit? Right. If I do another action, what will be the benefit? Right? And then after every action, you go to a different state. Right? So for example, like let's say, if I go out, it's raining, right? So I will get wet. So the action is like, let's say if I'm going out, right, and it's raining, I will get wet. So that's a state, that's a reward. Reward may be positive or negative, right? So these are kind of scenarios that are built over time. Right, and there are like thousands of scenarios. It's not like just 1 or 2 cases. So it builds thousands of scenarios, and then it identifies a pattern that what is the action that gives the best reward, what is the action that is the beneficial, and that is how then the algorithm learns. right? So there are the three broad categories, right? We have a past data with actual output, which you use it. So this is like more of a correlation kind of scenario where you correlate inputs to output. The third one is that you don't have the actual output data. You just have the inputs as such. Right? And then third is that you have that action reward kind of scenarios. Right? What if you do a particular action, what is the outcome? And then based on that, you actually build the algorithm. Yeah. Okay. Yeah, I think this I won't cover in detail, but basically when it comes to AI, right? So there are two broad categories. I think the overall goal or the long-term goal for all those AI scientists and all is to achieve a general AI. So general AI means the AI will actually be exactly similar to human intelligence in terms of other aspects also. So we saw one aspect is identifying pattern. Right? So like, let's say if I give a diary, it will identify that this is a diary, right? But there are other aspects of human intelligence, which is like, let's say mainly the emotions. So the long-term goal, like some of these AI enthusiasts that they have is like how we can build, like, let's say emotions or like, let's say logic, and basically make it closer to human intelligence in other aspects also. Even the reasoning, even like some of the ethical part, right? I mean, human, as such, we have some ethics. We say that, okay, we should not do this, we should not do that, right? Now that as such AI doesn't know on its own, but they are trying to build some of these aspects also. So that is the general AI, which is like, let's say the consciousness, which is like what awareness of self and then emotions and all. Then autonomous decision making and all that. So yeah, I won't get into details, but basically currently what we have is like all what is called as narrow AI, which is like identifying patterns and all. We are not so much yet achieved, let's say, general intelligence. Right? Okay. Okay. So AI types by usage. So these are like kind of algorithms that, I mentioned like supervised and unsupervised, these are like types of, let's say, algorithms, but these are now some of the specific algorithms. So like, let's say regression. So regression is, so we assume a kind of a linear association between input and output. So one example that is commonly given is like, let's say age versus height in the kids, right, in the children. So in the children, like, let's say as the age is higher, typically height is higher, right? I mean, till certain age, till maybe 18, 20 years. Right? So now that is a kind of association that the AI model builds. So we give the input, like let's say we give a set of student data, like let's say the age and then the height. We give like, let's say the entire SP college students, right? We give that kind of data. And then, so it's a regression problem. So it will try to identify linear relation. It will try to say like, let's say if the age is like, let's say instead of 15, if it is 18, then the height may be X plus Y, right? So it builds that kind of association. That is the regression kind of model. Don't have example here, but yeah, I think that height and age is a typical example. Some other examples. So I mean, this is just one parameter, right? But in reality, there are like multiple parameters. We have like lots of input parameters, and then based on that, we generate the output. Then there's a classification. I think I talked about that classification of pictures, classification of, let's say, objects, all of that. Even the credit risk assessment, right? That's a classification. We classify whether the applicant is risky or not risky. Then there's a clustering. So clustering is used for grouping of the items. I think the photo classification can be one example. But other example that is used, especially let's say in the commerce side or the marketing side is grouping of customers, what is called segmentation of customers. So we say that certain customers are of certain type. We give, certain kind of attributes to the customers. So one customer, like maybe we can say that one customer is very likely to buy this kind of item. Certain customers may not buy that kind of item. So we give different groups of customers. So typically we can say like, let's say, demographic wise, we can say like urban customers is like one set, rural customers are like another set. Obviously their purchasing requirement as well as patterns are different, right? We can have clustering based on that. Then natural language processing, which I think now you know. So ChatGPT is kind of a best example for this. So natural language processing is we give the text data and it identifies again the patterns in the data. It identifies what user is actually talking about. Or so there are multiple steps. So when you give a sentence, it breaks. Okay. So it